Voyager 1, a tiny spacecraft about the dimensions of a vehicle, is drifting through the unattainable darkness of space, 14.5 billion miles from Earth. Released in 1977, it was originally designed to last only 5 years. But almost 50 years later, Voyager remains alive, defying the odds. Lately, something bizarre has been happening. It is sending back signal patterns, pulses, and records that do not make sense. Should Voyager have discovered something in the void among stars? Or, even more chilling, has something out there discovered Voyager? The tale of Voyager begins not with spaceflight, but with an extraordinary cosmic alignment. In the early 1970s, astronomers realized something incredible was about to happen. Jupiter, Saturn, Uranus, and Neptune would soon align in a formation that takes place only once every 175 years. This alignment would allow a spacecraft to visit all 4 planets in a single mission, using each planet's gravity as a slingshot. To the next, NASA could not resist this cosmic opportunity. They began designing twin spacecraft that could survive the harsh radiation around Jupiter, the unknown dangers of Saturn's rings, and the decade-long journey through the outer solar system. This was the birth of the Grand Tour project, later renamed Voyager. The spacecraft themselves were marvels of 1970s engineering. Each Voyager probe weighed approximately 1/800 lbs and carried 11 scientific instruments. They were powered by radioisotope thermoelectric generators, RTGs, basically nuclear batteries that convert heat from decaying plutonium into energy. Solar panels would have been useless in the dim light of the outer planets. Building the Voyagers was a massive mission. Engineers had to design systems that would function perfectly for years without any possibility of repair. They built in multiple backups for critical systems and programmed the computers to diagnose and fix their own problems when possible. The onboard computer had about 68 kilobytes of memory, less than what it takes to store a single digital photo. Today. On August 20th, 1977, Voyager 2 lifted off from Cape Canaveral. It launched first, despite being number 2. 16 days later, on September 5th, Voyager 1 followed, riding into space atop a Titan III rocket. Because Voyager 1 was on a faster trajectory, it overtook its twin to reach Jupiter and Saturn first. As the 2 probes sailed away from Earth, few could have imagined that nearly half a century later, one of them would still be making headlines, not for what it was discovering, but for what might have discovered it. Voyager 1's journey through our solar system was nothing short of remarkable. After about an 18-month cruise, it made its closest approach to Jupiter in March 1979. What it saw there transformed our understanding of the gas giant. Jupiter, viewed from Earth-based telescopes, had always appeared as a pretty but simple striped ball with a mysterious red spot. Through Voyager's eyes, Jupiter became a world of stunning complexity. The Great Red Spot, observed since the 1600s, was revealed to be a massive storm system capable of swallowing 3 Earths. The colorful bands were not just pretty patterns, but raging storms and jet streams moving at hundreds of miles per hour. Jupiter's moons stole the show. Io, the innermost large moon, stunned everyone when Voyager observed active volcanic eruptions occurring in real time, the first active volcanoes ever seen beyond Earth. These volcanoes spewed sulfur compounds that painted Io's surface in yellows, oranges, and reds, like a cosmic pizza. Then there was Europa, a smooth white moon covered in cracks like a shattered eggshell. Voyager's images led scientists to theorize that beneath its icy surface might lie an ocean of liquid water, a theory later strengthened by subsequent missions. Europa remains one of our best hopes for finding alien life in our solar system. After Jupiter, Voyager 1 raced toward Saturn, reaching the ringed planet in November 1980. What had seemed simple from Earth became gloriously complex up close. Saturn's rings, which appear as solid bands from Earth, broke down into thousands of individual ringlets, some braided, some with strange spokes, all moving and changing like a cosmic dance. Saturn's largest moon, Titan, particularly fascinated scientists, as it was the only moon in our solar system with a thick atmosphere. Voyager couldn't see through Titan's orange haze, but measured its atmosphere and found it was mostly nitrogen, much like Earth's. This discovery would later lead to the Cassini-Huygens mission, which found lakes and rivers of liquid methane. On Titan's surface, after Saturn, Voyager 1's planetary mission was complete. NASA had a choice: send it to Pluto, then still considered the ninth planet, or direct it northward, out of the plane of the solar system, to begin its journey into interstellar space sooner. They chose the latter, while Voyager 2 continued on to Uranus and Neptune. As Voyager 1 left Saturn behind, it turned its camera back toward the planets for one last look. In February 1990, at Carl Sagan's suggestion, it took a series of images that included what became known as the pale blue dot photo. Earth, a tiny blue pixel in a sunbeam, seen from 3.7 billion miles away. Sagan's reflection on this image became one of the most profound statements ever written about humanity's place in the cosmos. Then Voyager 1 fell silent, at least visually. NASA turned off the cameras to save power, and the spacecraft sailed into darkness, blind but still sensing, still listening, still sending back data about the space between the stars. Attached to the side of each Voyager spacecraft is a gold-plated copper disc, 12 inches in diameter, a time capsule meant to tell the story of Earth to any intelligence that might find it in the distant future. The Golden Record, as it's known, is humanity's message in a bottle, tossed into the cosmic ocean. The story of the Golden Record is almost as fascinating as Voyager itself. NASA gave a team, led by Carl Sagan, just 6 weeks to decide what to put on it. 6 weeks to sum up all of human existence. The team worked around the clock, debating and arguing passionately, approximately what music, sounds, and pictures ought to constitute our world to the stars. The very last contents are terrific in their diversity. The record consists of greetings in 55 languages, from Adian, a language spoken 6,000 years ago, to Wu, a Chinese dialect. There are sounds from Earth, thunderstorms, volcanoes, birds, whales, laughter, footsteps, and a human heartbeat. There's music from around the world: Bach's Brandenburg Concerto, a Navajo nighttime chant, a Peruvian wedding song, and Chuck Berry's Johnny B. Good. The record also includes 116 images encoded in analog format, diagrams showing mathematical concepts, photos of Earth's landscapes, photos of human activities, and illustrations of DNA structures. There's a message from then-President Jimmy Carter and UN Secretary General Kurt Waldheim. On the cover of every record is a diagram showing how to play it at 1623 revolutions per minute, along with a pulsar map showing Earth's location in the galaxy. The records are expected to last for billions of years, long outlasting Earth itself. The chances of an alien civilization ever finding a Voyager spacecraft are especially small. The nearest star to Voyager 1's trajectory is AC, Scene 3888, which it will pass in about 40,000 years. Even then, it will still be 1.7 light-years away. But that wasn't really the point. As Carl Sagan said, the record was a kind of symbolic statement, a way of saying, "We made it this far. We hope you exist." There's something profoundly moving about those golden records, still traveling outward, carrying the sounds of babies' laughter, whale songs, and Bach into the endless darkness. They represent humanity at its most hopeful and forward-thinking, the same spirit that built the Voyagers themselves. Little did we know that the Golden Record might not be our first message received by another intelligence, because something out in the darkness between stars seems to have taken an interest in Voyager itself. After its encounters with Jupiter and Saturn, Voyager 1 entered what engineers called the cruise phase, a seemingly endless journey through the outer solar. system with no more planets to visit. Public interest waned as the spectacular images stopped coming. NASA's focus shifted to newer missions like the Hubble Space Telescope and the Mars rovers. But Voyager kept going, traveling about 1 million miles every day, gradually moving toward the edge of our solar system, wherever that might be. Scientists weren't entirely sure where the solar system ended. They knew the sun creates a protective bubble called the heliosphere, where the solar wind, a stream of charged particles from the sun, pushes against the interstellar medium. But they didn't know exactly how large this bubble was or what lay beyond it. During these quiet years, Voyager continued to send back invaluable data about the outer solar system. It measured how the solar wind changed with distance, mapped magnetic field lines, and detected cosmic rays, high-energy particles from beyond our solar system. This information helped scientists build better models of how our sun interacts with interstellar space. Life on board Voyager during these many years was a constant battle against the inevitable. Its power supply, fueled by heat from decaying plutonium-238, loses about 4 watts each year. Engineers had to make tough decisions about which instruments to keep running and which to shut down forever. The cameras went dark in 1990, and other instruments followed as power diminished. Meanwhile, the distance between Voyager and Earth grew, making communication increasingly difficult. The signal from Voyager became so faint that only NASA's largest antennas in the Deep Space Network could detect it. By the 2000s, it took over 14 hours for a radio signal, traveling at the speed of light, to make the one-way trip. But Voyager 1 kept transmitting, sending back data from a place no spacecraft had ever reached before. The boundary between our solar system and the vast, cold darkness beyond. In 2012, Voyager 1 finally passed beyond the heliopause, the outer edge of the heliosphere, entering interstellar space for the first time. It became the first human-made object to leave the sun's protective bubble, marking the beginning of a new era of space exploration. The data it returned revealed a new environment, filled with galactic cosmic rays and different magnetic fields than those inside the heliosphere. But even beyond this frontier, Voyager 1's signals have recently baffled scientists. They've detected mysterious pulses and patterns that don't correspond to any known spacecraft system or natural cosmic phenomenon. Some speculate it could be evidence of an unknown astrophysical process. Others wonder if it might be a sign of extraterrestrial intelligence. Whatever the truth, Voyager 1 continues to send messages back to Earth almost 50 years after its launch, reminding us that even in the farthest reaches of space, our quest to explore and understand continues without end. Voyager 1's sudden signal anomalies began to draw increasing attention from scientists at NASA's Jet Propulsion Laboratory. Engineers initially suspected a technical glitch. After all, the spacecraft is far beyond its intended lifespan, and decades of cosmic radiation could have damaged its electronics. But the patterns didn't match any known failure or noise typical of a spacecraft of its age. Instead, these signals appeared as bursts of regular pulses, sometimes encoded sequences, that defied simple explanation. Some researchers proposed that Voyager's instruments might be detecting unknown cosmic phenomena, such as pulsars or rare interstellar particles creating interference. Others theorized a more astonishing possibility, that Voyager 1 might be receiving signals or energy from an alien source somewhere in the local interstellar medium. This hypothesis was met with skepticism but also fascination. The idea that Voyager, humanity's most distant emissary, might have become a sort of cosmic beacon or receiver for extraterrestrial communication captured imaginations around the world. Meanwhile, the spacecraft itself continued its silent voyage, relentlessly, drifting outward at about 38,000 MPa. The vastness of space surrounding Voyager is nearly incomprehensible, a near-perfect vacuum, temperatures approaching absolute zero, and radiation from distant stars filling the void. Voyager is currently traveling through a region called the local interstellar cloud.